I will explain to you while loops in Python. What's a while loop? Or why do we use while loops? We use while loops to repeat tasks as long as a certain condition is true. First, the condition is evaluated. If the condition is true, then some statements are executed, and then the condition is checked again. So these statements will be continued to be executed as long as the condition is true. When the condition will be false, it will continue with the next statement in the program. How do we write this in Python? We write the keyword, Python keyword while, followed by a condition, or a condition can be also set as a logical expression, which will evaluate to either true or false. If the condition is true, the statements inside the while is executed, and then the condition is checked again. And as long as the condition is true, those statements will be repeatedly executed. Let's see some examples about these. Assume I want to print 1, 2, 3, 4. Okay. We can do this quite easily with a for loop, but we can also do it using a while loop. What is the initial value? The initial value is 1. I want to print 1, 2, 3, 4. So my initial value is 1. I assigned that value to a variable, and I check in a while loop, in the condition of the while loop, I check if it is less or equal to 4, because 1, 2, 3, and 4 are all less or equal to 4. I print the count variable, and then I increase the count variable. So what will be the values of count? Count will be 1 at the beginning. It is less than or equal to 4. 1 is less than or equal to 4. So 1 is printed and count is made 2. It checks again after finishing the body. This is the body of the while loop here in this program. Lines 7 and 8 makes the block of statements in the while loop. After these two statements are executed, we check the condition once more. Now count is 2. 2 less or equal to 4. Yes, print 2. Increase the count by 1, and then count will become 3. 3 less or equal to 4 is true. Print 3. Increase the count variable to make it 4. 4 less or equal to 4 is true. Print 4 and increase the count variable to make it 5. Now 5 less or equal to 4 is false. Therefore, it will continue with the next statement in the program. And after the while loop, as we see, when we print the count after the while loop is executed, we see that it is 5. Here we have a loop in which we increase not 1 by 1, plus equal is equivalent to count is equal to count plus 1. Increase the variable count by 1. If I have count plus equal to, the meaning of this is to increase the variable count by 2. Or I can write this statement also like this. Okay. Now we want to print the even numbers, the positive even numbers less than 10, up to 10. Let's write here that command print positive even numbers up to 10. So what we do, we start with 2. The first number that we will print is 2, and then we will print 4, 6, 8, etc. Therefore, inside the while loop, at the end of the while loop, we will increase the variable by 2. And here we check if it is less than 10, because it prints positive numbers up to 10. Therefore, it has to be less than 10. So if the variable count is less than 10, print it and increase it by 2. And as we see, when the loop is finished, at one time count will be 10. 10 less than 10 will be false. It will quit the loop and continue with the next statement, and we see that it will print 10 for count. Here we have another loop where we print numbers 10 to 0. We are doing a countdown. So we say, of course, it will not be seconds, but it is just some numbers. Don't think about seconds now. This is just any variable. I just named it seconds. The time that will take for this program to run this part will be probably a few nanoseconds or milliseconds, but it doesn't matter. It will print 10 to 0. So the number at the beginning is equal to 10. As long as it is greater or equal to 0, I want to print, because I want to print the value 0 as well. Therefore, it will be 10, 9, blah, blah. At the end, it will be 0. And after 0, it will be -1. But I don't want to print -1. Therefore, I want to print up to 0 in decreasing order. Therefore, as long as the seconds is greater or equal to 0, we will continue to print. I want to print on the same line. That's why I used and is equal to 1 space in the between quotation marks. There's a space here. Print the variable seconds, and then instead of going to the next line here, for example, we don't have any other thing. Print count, prints the count, and goes to the next line, next line, next line. But this time I want to print them all on the same line. That's why and with a space between them. Therefore, I used the end parameter of the print function with a space string, which contains a single space. So 10 less or equal to 0, yes, print 10 with a space after it. Decrease the seconds variable by 1, so it will become 9. Print 9, 8, blah, blah. At one time, it will be 0. 0 greater or equal to 0 is true. Print 0 here, the last one, 0. And then decrease the variable seconds by 1. So it will be -1 after 0. -1 greater or equal to 0 will be false. Therefore, it will quit the loop and will continue with line 28. And it will write after while statement, the value of the seconds will be the variable seconds will be -1. I don't know if you have heard Fibonacci numbers before. What are Fibonacci numbers? The Fibonacci numbers starts with 1 and 1, and every next Fibonacci number is equal to the addition of the previous two. 1 plus 1 is equal to 2. Then next, 1 plus 2 is equal to 3. 2 plus 3 is equal to 5. 3 plus 5 is equal to 8. 5 plus 8 is equal to 13. So every new number is equal to the sum of the previous two numbers. 8 plus 13, 21. 13 plus 21 is the next number, which is 34. 21 plus 34, etc. 55, 89, 144, etc. These are Fibonacci numbers. Sometimes you can see that it starts with 0 and 1. It may start either with 0 and 1 or 1 and 1. It doesn't matter, because after 0 and 1, 0 plus 1 is 1. Then 1 plus 1 is 2. The rest is same, okay? Either you can start with 0 and 1 or 1 and 1. It doesn't matter. In my program, I want to print Fibonacci numbers which are less than 200, okay? And on the same line. So we are printing Fibonacci numbers, blah, blah, less than 200. We are printing a string here in a print statement. What I do, the programming for the Fibonacci numbers is not as simple as other problems. What I do, I use two variables. Let's put here some extra spaces so that I will explain this to you. I assume that the variable f1 is equal to 1, and the variable f2 is equal to 1 again. Okay. At the beginning, I assign the first value to f1 variable and the second value to f2 variable. Here I use Fibo1 or F1, it doesn't matter. Fibo1 is equal to 1. Fibo2 is equal to 1 as well. These are the first two numbers. And we are printing the first two numbers, Fibo1 and Fibo2. And what I do after that, I create a new variable, Fibo3, which is the next Fibonacci number, which is equal to the previous two Fibonacci numbers. So here in my program, when I add F1 and F2, Fibo3 or F3, let's call it F3, let's abbreviate it F3, it will be equal to F1 plus F2. So 1 plus 1 will be equal to 2. And as long as the new Fibonacci number is Fibo3 for us at this time. As long as the new Fibonacci number is less than 200, we print the new Fibonacci number. So here 1 and 1 were printed, 1 and 1. Fibo1 is 1, Fibo2 is 1, Fibo3 is now 2. Maybe it is better to build a table here. Let me this. Okay, this is the variable Fibo1 in the program. Here I have Fibo2 in the program and Fibo3 in the program. At the beginning, I assigned 1 and 1 to Fibo1 and Fibo2. So what happened? Here, let's make this. Let's center. 1 and 1 are assigned. So what I do, Fibo3 is equal to Fibo1 plus 2, which is line 36 in my program. So 1 plus 1 is equal to 2. 2 is less than 200. OK. The new Fibonacci number is always in Fibo3. This is the first Fibonacci number, second Fibonacci number, and after that, in my program, always Fibo3 will contain the next Fibonacci number. Here at the beginning, these are the previous two numbers. The next number is 2. So we print 2. Then what we do, we assign this value to F1. So F1, instead of being that number, it will be that number. And F2 will be that number. So here I have an assignment which assigns Fibo2 to Fibo1 and Fibo3 to Fibo2. So what do? We put this 1 to Fibo1 and this 2 in Fibo3 to Fibo2. So we shift the values, OK? Always Fibo2 becomes Fibo1 and Fibo3 becomes Fibo2. The values are shifted. Now, this is the case. These F1 and 1 and 2 are F1 and F2, Fibo1 and Fibo2. And then what we do, Fibo3 is equal to, again, the previous two numbers. So 1 plus 2 is 3. We come back to the beginning of the while loop on line 37. 3 less than 200, yes, print 3. And then shift the variables again. Fibo2 is assigned to Fibo1, so 2 is assigned here. Fibo3 is assigned to Fibo2. And we, on the next line, on line 40, we again add up Fibo1 and Fibo2 to get Fibo3, 5, 2 plus 3 equal to 5. Print 5 is less than 200, print 5, and continue doing the same thing. So 3 and 5 are shifted. We add these two to get 8. 8 is less than 200, print 8, then shift again. 5 is shifted, Fibo2 is shifted to Fibo1, and Fibo3 is shifted to Fibo2. 5 are shifted here, 8 is shifted here. We add these two, we get 13, etc. And we continue like this. So by using only 3 variables and by shifting the values, we get all the Fibonacci numbers. OK. At one time, this will be 34. This will be 55. Add this to 89. and then 55 is here, 89 is here. Add these two to get 144, and then shift again. 89 is shifted to FIBO 1, 144 is shifted to here. When we add these two, we get 233, I think. Yeah. So 233 is not less than 200. I am interested in all Fibonacci numbers up to 200. So we will be printing these numbers together with 1 and 1, and then these numbers, and then when it is more than 200 or not equal, not less than 200, we stop. We see the values here are printed on the same line. How we ensure that? We use the end parameter of the print function with a string containing a single space. So after printing any number, it doesn't go to the next line, but it just prints a space and stay on the same line. And here we have we are printing \n to go to the next line. After 144, it still stayed on that line. In order to go to the next line in my string, I printed new line, and after 200, the next Fibonacci number is printed here. This may seem a little bit complicated to you for the time being. In my program here, in my lecture notes, there is another way of doing it. It is like it is here. This is more complicated. That example is more simple. Here in the lecture notes, I used a slightly more complicated way of handling all Fibonacci numbers by only using 2 variables, not 3 variables, but by only we can also achieve this by using only 2 variables. And probably it is better to have that copied there. Control C. I will change my lecture notes because it is more difficult to understand this. Less than 100. Okay, because here it says Fibonacci numbers that are less than 100. So I just changed this from 200 to 100 because in the lecture notes it is only printing the Fibonacci numbers up to 100. Any questions about this example? I advise you to go over these examples and try to, if you didn't understand right now, try to understand later on at least, or ask question to me and I will explain to you again. Now, next example. I want to print powers of 1.2, 1.2, 1.2 square, 1.2 cube, etc. Powers of 1.2 that are less than 10. So what is my initial value? 1.2. As long as this number is less than 10, okay, then we continue our while loop. We print the number, and by multiplying the number itself with 1.2, I get the next power of 1.2. Okay, 1.2 multiplied by 1.2 is square, and then again, if I multiply with 1.2 again, it will be power 3. Then if I again multiply by 1.2, it will be power 4, power 5, etc. So when I multiply the variable by 1.2 again, it's starting with 1.2 at the beginning, I get the next power of 1.2. As long as that number is less than 10, we are printing. Here is our output. 1.2 multiplied by 1.2 is 1.44. Multiply this again by 1.2, 1.728, etc., etc. And as you see, we have several powers of 1.2 that are less than 10. And we print those numbers. And when it is not less than 10 anymore, this condition will be, if it is greater or equal to 10, this condition will be false, and it will exit the loop. And after 10, we see that the next number, that the next power of 1.2 is 10.699 blah blah. Okay. Here you can see a number of nines, etc. So you can just remove everything here and put 4 here. But as I said before in one of the lectures, previous lectures, the real numbers cannot be represented exactly in computers. Okay. Some real numbers can be, for example, this one is exactly represented. This one is exactly represented, but this one didn't exactly represented. It should be, it has to be have, instead of 3999 blah blah here, it has to be 4, and instead of 79999 etc. it has to be 8. Instead of 599999 it has to be 6, etc. Since these numbers cannot be exactly represented in computer arithmetics, then you can get this kind of outputs from Python. Anyway, here there's another example. Inside here, almost always the variable that is used in the while loop, here, for example, num, or here Fibonacci, is changed somewhere in the while loop, usually at the end, but it can be somewhere else, not only at the end, it may be some before that. So because this condition has to be true for some time, and at some other time it has to be false, so that the while loop has to finish. Okay, therefore this variable, which is used inside the condition here, must be changed inside the while loop. This is another example, powers of 1.2 that are less than 20. It is very similar to power of 1.2 that are less than 10. It is same problem. Anyway, let's continue. I want to input numbers from keyboard as long as 0 is not entered. In order to stop, we will enter 0. Let's run this program again. I will show you what I mean. Now it says, for example, 8, 14, 9, 7, 12. Let's enter now 0. In order to stop, I will enter 0. So repeatedly, the program will ask me to enter a number. I will enter several numbers. And at the end, at some time, I will enter 0 to stop this process of entering. What I'm we input numbers till 0 is entered. And what I want at the end, after 0 is entered, 0 is not used. It will not be used in the computation. The other numbers 8, 14, 9, 7, 12 will be used. And what I'm interested in the sum and the average of the input numbers. What is the sum? 8 plus 4, 14, 22 plus 9, 31, 38, and 50. Right, just the sum is 50. How many numbers are there? 1, 2, 3, 4, 5. What is the average? 10. So after entering 0 and press this, I see that there are 5 numbers. The sum is 50, and the average is 10. Okay. So how do I achieve this using a while loop? There are 2 ways of doing it. I have one solution here and another solution below. First, let me explain this one. Before the while loop, okay, before starting the while loop, we input the first number. How do we input an integer number? We have an input, blah, 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 inside the int type conversion function. Because input gives us a string. When I enter 8, it will give me a string which contains double quotation mark, 8 double quotation mark, and 8 inside a string. Or when I enter 1 and 4 and press enter, the string given by the input function will be a string containing the character 1 and character 4. It will be a string, not a number. In order to convert to an integer number, I have to use the int conversion function. What is my condition? As long as it is not 0, I will continue inputting numbers. So my while loop has, as long as the value of n is not equal to 0, continue doing operation. But in order to check this at the beginning, n has to be assigned some value. It has to be the first value that is input from keyboard. That's why we have here the line 66. Input number, the first input number is before while loop. Here we input the first number. If the number is not equal to 0, like 8, or later on in the while loop we will continue doing with 14, 9, 7, 8, 12, etc. As long as the value of n is not equal to 0, what do? We increase the count variable, and we add that number, input number, to a variable that here I've called it sum1. Sum1 is equal to sum1 plus n. We have one new value, and we add that value to sum1. So here I use a variable count1 to count how many numbers, valid numbers, are entered. 1, 2, 3, 4, 5 here, 5 times. As long as it is not 0, we increase the count variable. We count the number of numbers entered, and we add each number to sum1. And after these two, I have to read a new number, because here in the while condition, I will check the next number. So I get the next number here. This statement is exactly like the previous one in line 66. I repeat this inside the while loop again. Here, this is executed on the line 66, is executed only one time, but here, this will be executed repeatedly. It will be executed many times. So enter number blah blah. This one is done on line 66, and all the rest, all the other enter number blah blah, is done on line 70 in the program. Okay. I need to do that here again. Why? Because for the next value of n, I had to check if it is not equal to 0 or not. If it is not equal to 0, then increase the count, add the number, and get the next number. So after some time, after here at the 6th step, I entered 0. So n will become 0. And here n became 14, then 9, then 7, 12, etc. And at one time, n becomes 0. I enter 0 from the keyboard. Therefore, when n will become 0, 0 not equal 0 will be false. Therefore, it will quit the loop, will come here. It printed count equal 5. It printed the sum of the numbers, which is put into sum1 variable, 50. And here, average is equal to the sum of all numbers and the count of all numbers. When we divide the sum with count, we get the average. I put the average in variable ave1. Ave1 is printed then here. Okay. Is this understood? This is quite common algorithm to input numbers. The next uses a break statement. Maybe I should spend a very small time to break. What a break statement do? A break statement causes to terminate a loop. Okay. So when we can't find a break in a while loop or for loop, it can be used in all types of loops. We can use the break statement in a for loop, or we can use break statement in a while loop. The break statement is almost always preceded with an if statement. If some condition happens, then don't continue, finish the while loop or for loop. So what we do here, This second part is exactly doing the same with the previous one. Sum of an average of input numbers, okay, till 0 is entered. Here there is another second solution. I again initialize the variables to 0. Now let's continue doing that. Enter this time 16 and then 87, 64, 35, 50, and then I will enter one more 21 and then 0. Now I've entered again. I'm doing very similar thing with the previous example, but the algorithm is slightly different. Sum to and count to are 0 at the beginning, and every time I have a valid number, I will increase the count, I will increase the sum. But here my while has the condition of the while statement contains true, which means that always repeat. Okay, since true is true, this will always repeat. So the only way to finish this loop is to use break statement. It will only finish the loop when break statement is executed. When break comes, it will continue with the next statement. Okay. So what do we do here in while loop? We input a number. All these inputs, okay, are done here on line 81. So after inputting the number here on line 81, we check if the number is equal to 0 or not. If it is equal to 0, we will finish the loop. Okay. If it is equal to 0, I don't want to continue to input any more numbers, and I will quit the loop. So if n equal to 0, then break follows the input statement. If n is not equal to 0, it will not execute line 83. Therefore, if n is equal to 16, 87, 64, etc., but one of these numbers, any non-zero number, it will continue with line 84. It's a valid number. If n is not equal to 0, it's a valid number. This is false. It will continue with next line. Count 2 is increased. The number that is input here is added to sum 2 and comes back and asks again. At one time, the user will enter 0. When at this line 0 is entered, now 0 is equal to 0 is true. Break will make the program continue with line 86. And here the count 2 is printed, the sum 2 is printed, the average is computed and printed as before. Let's print. Now I will hit enter key from my keyboard, and we see that the sum is 263. There are 6 numbers and the average is 45.5. Is this understood? I advise you to examine this program segment and this program segment. The functionality is exactly the same, but the algorithm is slightly different. In both we used a while. In one of them we use while true, and in order to quit the loop we used break statement. And in the first one we input the first number here, and at the end of the while loop we input the other numbers. All numbers except the first number are input on line 70, and each time after inputting this at the first number or inputting a number inside the while loop, immediately after this operation, input operation, or here input operation, immediately after this we check if the input value is equal to or not to 0. If it is not equal to 0, we will increment the count, we will add the number to sum and get the next input. Okay. Both are completely correct and valid ways of solving this problem. Any questions about these two examples? It is quite important to understand this example. No question? Then it seems that you understood perfectly well this example. Now there is a slight difference between this question and the previous one. I am not only interested in sum and average, but I am also interested in maximum and minimum of the input numbers. Now this is the first time you will see how maximum and minimum of a set of numbers is found. Here again, I have my sum and count variables. I input the first number here. Okay. There's a delicacy, there's a very tiny detail here. After inputting the first number, I assume that max and min values is this first number. Now let's go here. Let me take this somewhere else. Now I will enter several values. I will enter the values that I had entered here. 8. Now after entering 8 on line 95, what is max 1 and min 1? They are both 8. Okay. This value 8 is assigned to both max 1 and min 1. We will see why we are doing that. And then the rest is very similar to the loop here. Okay. It is quite similar to this one, to this example, with addition of computation of max and min, maximum and minimum. So if n is not equal to 0, the input number 8 is not equal to 0. So what we will be doing, we will be increasing the counter and we will be adding that number to sum. And then after doing that, increase the count and add the number to sum. And then we check if the new number, now let's enter, for example, 14. After entering 14 is the maximum of all these numbers entered. Okay. So what we do, if the new number is greater than the previous maximum, what was the maximum? Maximum was 8. Okay. The first number 8 was assigned to max 1. If 14 greater than max 8, yes, the previous maximum was 8. The new value is 14. Therefore, what we do, we assign 14 to max 1. Probably it will be a good idea to have something similar to this one. I will just erase this and I will add. Okay, this is n, this is count 1, sum 1, and max 1 and min 1. These are my variables, okay? And the values that I will enter will be at the beginning. I assign 0 to count and sum 1. And then we input the first number, which is 8. And since we are assigning 8 to max 1 and min 1 on line 96 and 97, what are we doing? Now this 8 is assigned to both max and min variables. And then next I enter 14. 14. What were the other values? 9, 7, and 12. I will enter then 9, then 7, and then 12. These are the numbers that I will enter. Now, when I enter 14 not equal to 0. Sorry, we come here. boom, 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 boom. Yeah. At the beginning, sorry, we didn't enter 14 yet. We assigned 8 to max and min. Sorry, I will correct my error. Now n is 8. Max 1 is 8, min 1 is 8. Count is increased. 8 is added to sum. 8 greater than 8? No. 8 less than 8 because at this time both n, max 1 and min 1, all three variables are equal to 8. This is false and this is false. So we come here, we input the next number. Now we are at this stage. When I will enter 14 and press enter, that 14 will be assigned to n on line 105. Okay, this statement will be executed. Now I entered 14. What will happen? 14 is entered. 14 not equal to 0. Yes. Count is increased by 1. Sorry, at the beginning it was 1 and 8. I forget this. 8 is not equal to 0. The first time n is 8 and 8 is not equal to 0. Increase the count, it becomes 1. Sum is added. So let's put here 8 and 8. Don't change anything here. 8 is added to sum 1. 8 not greater than 8 is not true. 8 less than 8 is not true. We input the next number 14. Now we are here. 14 not equal to 0. Yes. Increase count by 1. Count will be 2. Add 14 to sum 1. It was 8 plus 14, 22. Now we come on to line 101. 14 greater than max 1. The new number 14 now is greater than the previous maximum. Therefore, 14 greater than previous maximum, max 1. 14 is greater than 8. Okay. Therefore, this is true. What we do, we assign 14 to max 1. 14 is assigned to max 1. N is 14. 14 less than 8? No. Now we check if the new number is smaller than the previous minimum. If the new number is smaller than the previous minimum, then the minimum is this new number. Okay. If the new number is greater than the previous maximum, then we have to change the maximum to set it to the new bigger number. Or if the new number is smaller than the previous minimum, it is less than all previous numbers, then I have to change the minimum to this new small number. So here for 14, 14 less than 8, no, this is not true. Therefore, it's not the new minimum. We continue with the next value. 9. 9 is input. 9 is greater or equal to 0. No, not equal to 0. Yes. Increase the count. Make it 3. Add to sum. Make it 31. 8 greater than 14. Sorry, 9 greater than 14. No. 9 less than 7. Here. No. Don't change anything. Input the next number. We input 7. After inputting 7, we come here to line 98, and is not equal to 0. Therefore, we continue with increasing the count by 1. Add the number to someone. Let's enter here 9 and 7. Here we don't see the changes in max and min because it's not printed. Anything is printed. We are only getting numbers. And then 12, and then at the end I will enter 0. So 7, the new n is 7. 7 greater than max 1, which is 14. No. 7 is less than min 1, which is 8. Is 7 less than 8? Yes. So here we put 7. I will change this slightly in this program because I want to enter a new minimum or maximum, for example, 16 and then 4 and then 10. I will continue with these numbers because I want to show to you some variations of max and min values. So after 12, we have 16 and then 4. Oops, sorry. And then 10 and then 0. I will enter 10, and after 10, I will enter 0. So these will be the values that I will enter after 10, and I will enter 0, and I will see the result. So after 7 is less than 8. This new number is less than the previous minimum, which was 8. We set the minimum to this new number. Then we get 12. Increase the count at 12, 50. Is 12 greater than previous maximum, which is 14? No. Is 12 less than the previous minimum, 7? No. We continue. Get 16. Increase the count. Add it to total. Is 16 greater than the previous maximum, which is 14? Yes. Therefore, maximum is updated. Is 16 less than the previous minimum? No, don't change it. Input 4. 4 is not equal to 0. Increase the count 1 by 1. Add this 4 to 66, which to make it 870. Is 4 greater than the previous maximum? No. Is 4 less than the previous minimum? Yes. Therefore, change the minimum to this new number. Input 10. Is it 0? No. Increase the count. Add. Make it 80. Is 10 greater than the previous maximum? Previous maximum now is 16. No. Is it less than the previous minimum? No. Don't change max and min. Input 0. When 0 is entered, we exit the loop because on line 98, we were saying while n not equal to 0. So some count, there are 8 numbers, sum is 80, maximum is 16, and minimum is 4, and 80 divided by 8 is 10.0. Okay, so 16 and 4, the maximum and minimum are found. So this is how we find a maximum. When we get a new number, we compare it with the previous maximum. If the new number is greater than the previous maximum, then we update the previous maximum or the maximum to the new number. Or to find the minimum, after getting a number, we check if the number is less than the previous minimum. If it is less than the previous minimum, then we update or we change the previous minimum variable. Why did we start at the beginning with the first number? I cannot assign 0 or 99 or something because I can enter some negative number, then the minimum value may be -5, and the maximum can be 200,000, something like that. So at the beginning, I don't know what can be the maximum or minimum. Here, I assume that my numbers will not be less than 1 billion and greater than 1 billion. So we start the maximum with a small number, the minimum with the big number, and this is again has the while true input number, and this is the same as before. These lines are same as the previous example, but here we use while true. I will not explain this. I will finish the lecture right now, but go through this and try to understand this. This will be a very good example to understand the maximum and minimum, also the while loop and the break. Here, I assign, try to input some numbers and try to see how maximum and minimum changes. Okay. Just go over this and try to understand this. Now it is 6:55, so I will finish my lecture. Any questions? If you remind me tomorrow, I can explain this to you, okay? Like with a table similar to this one. Any questions?